Hello students, in the last class we saw about the analog and digital signals. Okay, so and also we came to know about the impairment. Okay, so what is impairment? When the data signal is passing from the sender to the receiver, there will be different imperfections in the transmission medium, so which causes different impairments. What are the causes of impairment? There are three causes of impairment, that is the main causes of impairment. One is attenuation, second one is distortion, and third one is noise. Okay, so first we will learn about the attenuation now. So attenuation andre enu andre, so it is the loss of energy. In simple term, it is loss of energy. Okay, so when a signal or the data is passing from sender to receiver, there will be some energy, right? So a part of this energy, when it is lost, it causes what? Attenuation. Okay, so attenuation adag enagutte anta heli ee figure alli ನೀವು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. So this is the signal which is sent from the sender. Okay, point 1 is the sender. Okay, ಈ point 1 ಅಲ್ಲಿ ನೋಡಿ signal ಹೇಗಿದೆ, it is in this form, right? So after this, what is happening at point 2, attenuation is coming into the transmission medium. Okay, na attenuated signal, this is the attenuated signal. Okay, so in attenuated signal, what is happening? The original signal which is passed is being attenuated, change agide, hauda? So this changed attenuated signal is passed through amplifier. Okay, for correcting the signals, we are passing the signal through the amplifier. So amplifier in the hodag enagutte, we will get the exactly same signal which was passed by the sender. Fine, artha aita nimage? So what is attenuation then? It is the loss of energy when a signal travels through different transmission medium. Okay, for example, let's see an example for this attenuation in electrical wires. Okay, so in electrical wires also electrical signals are passing. Electrical signals pass agta enagutte, there will be heat generation, right? Heat generation agi enagutte, part of the signal is being lost. So okay na, so amele adinda henge ನಾವು ಕರೆಕ್ಟ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ, these attenuated signals can be corrected through what? That is amplifier. By introducing amplifier, we can correct the attenuated signals so that the receiver receives the signal which is actually sent by the sender. ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? ಸೆಂಡರ್ ಏನು ಸೆಂಡ್ ಮಾಡ್ತಾನಲ್ಲ, ಆ ಸಿಗ್ನಲ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಒಳಗೆ ಬಂದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? there will be attenuation. Attenuation ಅಂದ್ರೆ loss of energy. Okay, a part of energy of the signal will be lost. Loss ಆದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? the signal will be changed. Okay, so then to correct these signals, what is introduced? We will introduce amplifier. So amplifier, what it does? It corrects the attenuated signal and exactly the same signal is passed to the receiver which is passed by the sender. Fine. So this is about the attenuation. So now you can see a word there, decibel, right? So what is decibel means? It is used by the engineers to measure the signal strength. Okay, decibel is also the measure of sound, right? Like that only. This is this what it is used for is, the decibel is used for measuring the strength of the signals, both at point 1 and point 2. Okay na? So enagutte anta helidre, so this is given by a value, that is dB equal to 10 log base 10 P1 by P2. So what is P1 P2? It is a power of signals at point 1 and point 2. Okay na? So this is about the decibel. Okay, I hope you have understood about the what? Attenuation. Attenuation anta helidre enu? It is loss of energy, by which it is also an impairment which causes loss of energy in the signal. So once the energy is lost in the signal which is sent by the sender is changed. So to correct this attenuated signal, what is introduced? The amplifier is introduced. So amplifier, what it does? It corrects the attenuated signal. Fine. So this is about the attenuation. So next let's see about the distortion. So distortion means change. See, you can see here, signal changes its form or shape. So the form of the signal is changed. As you can see in the diagram, see, this is the signal which is sent by the sender. At the sender side, the signal look like this. Okay. After the receiver receives the signal through different transmission impairments, what is happening? The form of the signal is only being changed, right? So this is called as distortion. So when this distortion occurs, when different signals of different frequencies are sent through transmission medium. Okay, so what will happen is every signal will have its own speed. So what will happen then? There will be delay, right? Once the sender sends the signals of different frequency, what will happen? The fastest signal will move first, and the slowest signal, what it will do? It will move slowly, right? So then what will happen? The signal will change its shape or form, right? So then what will happen? The signal will undergo distortion, right? ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? ಏನಾಗುತ್ತೆ, ಬೇರೆ ಬೇರೆ ಸಿಗ್ನಲ್ಸ್ ಅನ್ನ ಸೆಂಡರ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಕಳಿಸಿದಾಗ, ಬೇರೆ ಬೇರೆ ಸಿಗ್ನಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರೋ ಸಿಗ್ನಲ್. ಸೊ ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರೋ ಸಿಗ್ನಲ್ ಅನ್ನ ಒಟ್ಟಿಗೆ ಒಂದೇ ಸತಿ ಕಳಿಸಿದಾಗ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಒಂದೊಂದು ಸಿಗ್ನಲ್ಗೆ ಒಂದೊಂದು ಸ್ಪೀಡ್ ಇರುತ್ತಪ್ಪ. ಅದೇನಾಗುತ್ತೆ, ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಏನಾಗುತ್ತೆ, the fastest will go first and slowest will go last. So then what will happen? The shape of the signal will get changed, right? So that causes what? Distortion. So I hope you are clear about this. Okay, so what is attenuation? Attenuation is loss of energy, and when distortion is change of the form or shape in the signal, right? So next, this was about the distortion. Now let's see about the noise. Third important impairment, that is noise. So what is noise? Means noise can be of different types of noise will come. Okay, not only one type of noise, there will be different types of noise in the transmission medium. So some of them are thermal noise and induced noise and crosstalks, and impulsive noise. So these are the important kind of noises which we see in the transmission impairment. Okay, so the first one is thermal noise. So thermal noise anta helidre eno, it is nothing but random motion of electrons, okay, which will produce heat and all, right? In electrical transmission medium, this will occur more. Okay, thermal means random motion of electrons. Okay, random motion of electrons. So we have seen about the thermal noise. Now what is thermal noise? It is caused by the random motion of electrons. And what is induced noise? Induced noise means it comes from different motors and appliances. Okay, so in computers or appliances is called induced noise, right? So then the next one is crosstalks. Crosstalks means it will come from different transmission medium. In crosstalk best example anta helidre, you will be trying to connect to someone's phone, right? So ನೀವು ಯಾರ್ದೋ ಫೋನಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಿರ್ತೀರಾ, someone else will pick and they'll start talking, right? This is called as crosstalks, right? Different transmission will cause the crosstalks. Okay, so the last one is impulsive noise. So these are this is spikes that cause from power lines and lightning and so on. So these are impulsive noise anta helidrenu. So these are the noises which is caused by lightning. Okay, so power lines lightnings inda ಏನು noise ಬರುತ್ತಲ್ಲ, so these are called as the impulsive noise. Okay, so these are the different types of noise. So now let's see the diagram for noise, how the noise actually works in the transmission of data from data or signal from the sender to the receiver. So this is point 1, right? Point 1 and point 1, or you can call it as sender, and at the center what is being transmitted, a signal is being transmitted. Okay, so this is the transmitted signal, so you can call it transmitted signal. Okay, so what is happening in the transmission medium? This is transmission medium. Okay, this is transmission medium. As I told you, the transmission medium can be both wired or wireless. Okay, so this is point 2, or you can call it receiver. And in the middle of this transmission medium, what will happen? There will be different types of noises. Which are the types of noises? As I told you, thermal noise, induced noise, crosstalks, or impulsive noise. These are the different types of noises which we can see in the transmission medium. So what will happen? The signal which is sent by the sender, when it passes through the transmission medium, it will face some noises, and once the see, imagine this is the noise. So what will happen? So this is noise. Okay, so when the transmitted signal passes through the noise, what will happen? The signal will change itself. Okay, so what the receiver will get? It will be different type of signal. Okay, so this is the receiver. See, this is the signal which is sent by the sender, but due to the noise, what is happening? This is the signal which is received by the receiver. ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? ಸೆಂಡರ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಒಂದು ಸಿಗ್ನಲ್ ಕಳಿಸ್ತಾ ಇದ್ದಾರೆ, ಅದು ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಮುಖಾಂತರ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ there will be noise, has an impairment. ಆ noise ಆ ಸಿಗ್ನಲ್ ಗೆ ಇದು ಆದಾಗ ಏನಾಗುತ್ತೆ? ಅದೇನಾಗುತ್ತೆ? It will change its form, right? So this is what is called as noise impairment, right? So I hope you are clear with this. So ಇದು ನಾವು ಏನ್ ಮಾಡ್ತಾರೆ, ಇಂಜಿನಿಯರ್ಸ್ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, to find the bit rate of the signal. Bit rate ಅಂತ ಹೇಳಿದ್ರೆ ಇಷ್ಟು ಟೈಮ್ ಅಲ್ಲಿ ಎಷ್ಟು ಸಿಗ್ನಲ್ಸ್ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ, ಓಕೆನಾ, ಫ್ರಮ್ ದ ಸೆಂಟರ್ ಟು ದ ರಿಸೀವರ್. ಇದು ನಾವು ಬಿಟ್ ರೇಟ್ ಅಂತ ಕರಿತೀವಿ. ವಿ ವಿಲ್ ಸ್ಟಡಿ ಅಬೌಟ್ ಇಟ್ ಇನ್ ದ ಫರ್ದರ್ ಕ್ಲಾಸಸ್. ಸೊ ಈ ಬಿಟ್ ರೇಟ್ ಕಂಡುಹಿಡಿಯೋಕ್ಕೆ ದ ನಾಯ್ಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ದ ನಾಯ್ಸ್ ಇದಕ್ಕೊಂದು ಫಾರ್ಮುಲಾ ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ, ದಟ್ ಇಸ್ SNR ಅಂತ ಕರೀತಾರೆ. ಸೊ SNR ಅಂತ ಹೇಳಿದ್ರೆ ಸಿಗ್ನಲ್ ಟು ನಾಯ್ಸ್ ರೇಷಿಯೋ ಅಂತ. And it is given by average helps us in finding the bit rate. Okay, to know the ratio of signal power to the noise ratio, it helps us finding the bit rate of the signals. Okay, so this is about the noise, right? So what is noise? It is an attenuation. It is an impairment that is caused by the transmission medium. So there are different kinds of noises, that is thermal noise, induced noise, crosstalks and impulsive noise. So what is thermal noise? It is caused by the random motion of electrons in the transmission medium. Okay. So what is induced noise? It is caused by the motors and different appliances. Okay. So what is crosstalks? Crosstalks are induced by different other transmission mediums, okay, which are trying to connect. Okay. So then the last one is impulsive noises. Impulsive noises are those which are caused by power lines and what? Power lines and lightnings. Next, we have seen about the diagram of the noise, how the noise actually works on the signal which is passed from the sender to the receiver. So we have point 1 and point 2, that is sender and the receiver. What the sender does, he transmits the signal. Okay, so the signal is in this form. So in this form, what will happen when it is sent in the transmission medium? Transmission medium and in transmission medium there will be noise. So when it passes through noise in the pass again, the signal will change its shape. Okay. So the different signal will be received by the the receiver, right? So noise plays a major role in finding the bit rate. Okay, how much data or the bits per second the signal is sending. So to know this, we will use SNR. So what is SNR? Signal to noise ratio, that is given by average signal power by average noise power. Okay, so this helps in finding the bit rate, okay, of the signal. So today we have seen about the different impairments, right? So this is very important topic. So what is impairment now? Impairment andre now. So impairment is the every signal which passes through the transmission medium will face some imperfections in the transmission medium. So these imperfections causes what? Impairments. Okay. So there are three important impairment causes. That is, one is attenuation, second one is distortion, and third one is noise. So what is attenuation? Attenuation means loss of energy. Okay. And what is happening in attenuation? The signal which is passed from the sender is not the same as the signal which is received by the receiver. How the same irregular. So to correct this, what we are using? So we are using the amplifiers. So once the attenuated signal are passed through the amplifier, it gets corrected, and the exactly same what signals are sent by the sender are received by the receiver after amplification of the attenuated signals, right? So then we came across decibels. So decibels is used to measure the strength of the signal both at sender and receiver, and also at the middle, that is attenuation. Okay. So it is given by what? 10 dB equal to 10 log base 10 P1 to P2. P1 by P2. So P1 and P2 are the strength of the signals or power of the signals at point 1 and point 2. That is sender and receiver. Okay. So then we came across the distortion. Distortion means change of shape or form. Okay, of the signals. Change of shape or form of the signals. Okay, by different impairment, right? So that is about the distortion. And the next one is noise. Noise, what we have seen? there are different types of noise, that is thermal noise, induced noise, crosstalks and impulsive noise. We have seen all the types of noises, and what is thermal noise? It is caused by the random motion of electrons in the transmission medium, and induced noise is caused by motor and different appliances, and crosstalks are caused by the other transmission mediums, and impulsive noises are what? These are caused by power lines and lightnings, okay, and so on. So the figure represents the working of noise in a transmission medium. So what the signal actually is sent from the sender is not the signal which is received by the receiver, because it passes through noise in the transmission medium. Okay, so the bit rate can be calculated from the noise, that is from SNR, that is signal to noise ratio. So it is given by average signal power divided by average noise power, right? So this is about the impairment, okay, or how the signal actually passes through different imperfections in the transmission medium ಅಂತ ನೋಡಿದ್ವಿ. ಹೌದಾ? ಒಂದು ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಈಸ್ ನೆವರ್ ಪರ್ಫೆಕ್ಟ್. ಓಕೆ, ಪರ್ಫೆಕ್ಟ್ ಆಗಿರೋದಿಲ್ಲ. ದರ್ ವಿಲ್ ಬಿ ಡಿಫರೆಂಟ್ ಇಂಪರ್ಫೆಕ್ಷನ್ಸ್ ದಟ್ ಕಾಸಸ್ ಫಾರ್ ಇಂಪೇರ್ಮೆಂಟ್ಸ್. ಓಕೆನಾ? ಒಂದು ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮೀಡಿಯಂ ಇಂದ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ನಾನು ಇವಾಗ ಇಲ್ಲಿಂದ ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ ಮಧ್ಯದಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವೈರ್ಲೆಸ್ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ನಡೀತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು, ವೈರ್ಡ್ ಆಗಿರಲಿ ವೈರ್ಲೆಸ್ ಆಗಿರಲಿ, ಎರಡರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ನಾನಿಲ್ಲಿ ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತಿದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ ದ ಪರ್ಸನ್ ಹೂ ಐ ಆಮ್ ಸ್ಪೀಕಿಂಗ್ ಟು ವಿಲ್ ಹ್ಯಾವ್ ಸಮ್ ಡಿಸ್ಟರ್ಬೆನ್ಸಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಒಂದೊಂದ್ಸತಿ. ಹೌದಾ? ಸೊ ದಿಸ್ ಡಿಸ್ಟರ್ಬೆನ್ಸಸ್ ಆರ್ ದಿಸ್ attenuation, this impairments has to be overcome to for getting the exactly same signals from the sender to the receiver. ನಾನು ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನೋ ಅದು ಅವರಿಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ತಲುಪೋ ಹಾಗೆ ಆಗಬೇಕು. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಓವರ್ಕಮ್ ದಿಸ್ impairments. Okay, so in the next class we will study about the bit rate. Okay, so we will go deeply in finding the bit rate of the signals, right? So thank you so much.